Hello, pre-algebra. Mr. Lawrence here with your next flipped lesson. This one is on probability still. We're talking today about mutually exclusive events and mutually inexclusive events. And I know these are fancy words and some of you get upset at that. Mutually exclusive events are events that, sorry about that, that cannot happen at the same time. So for example, if you have a situation like you've got a six-sided die, like the one I have here, and you want to know the probability of rolling a number less than 3 or a 5, okay? The probability of rolling a number less than 3 or a 5. Now you could just simply count them up. There are 1, 2 numbers less than 3 on a six-sided die, and there's 1, 5 on a six-sided die, standard die that is. And so you could say it's 3 out of 6, or better said, it's 1/2. But if you weren't sure, you could take the probability of getting a number less than 3, which would be 2 out of 6. Why 2? Because there's a 1 and a 2, and they're both less than 3. And then a 5, there's only 1 5, so it'd be 1/6. And then because it's an OR, you're not going to multiply these together. You're going to add. You're going to add them up. 2/6 plus 1/6 is 3/6, which simplifies down to 1/2. So the probability of getting a 3 or a 5 is 1/2. And all we have to do is add the two probabilities because they're mutually exclusive. They cannot happen at the same time. Another situation could be, say, like if we have, let me bring this, oops, I want to bring that die down. Let's see if it'll let me do that. There we go. We have this die, and then let's say, well, actually, I don't want to do that one yet. Okay. Well, that's good for mutually exclusive, I think. So two events that cannot happen at the same time. All right, now we have mutually inexclusive. This is a little bit different. Okay, you might expect these are events that can happen at the same time. Okay, now you have to be careful with this because you do it very much like you would a mutually exclusive problem, except there's some overlap. Let's consider the idea that you have, say, a coin and a die. Let me get my die over here. Okay, and let me go find a coin. And, okay, my coin's a little bit large there. So I'll make it, oops. I will make my coin smaller. And I want to know this time the probability of rolling 2 or ahead. Okay. Now you might think, well, I'm just going to do the probability for getting a 2 and then the probability of getting ahead and then add them together. That's not quite going to work. And let me show you why. Let me make a little table here. These will be the possible outcomes for the die. All right. And I'll make a little table out of this. So my table will look like this, and I've got the HT for heads and tails, and I'm going to put a check mark on every one for the 2 that would be a success. So I'm going to put a check mark here for this 2, heads and a 2, tails and a 2, right? Okay. Now I'm going to put a check mark in red for this one. Everywhere a head shows up. This would be a 1 and a head. This would be a 2 and a head, a 3 and a head, a 4 and a head, a 5 and a head, and a 6 and a head. Now all the rest of these boxes would represent failures or not successes, times when I didn't win the game, so to speak. Now, did you notice anything unusual, particularly right here? This box got counted twice, and that shouldn't happen. We don't want to overcount. So I should only count one of those check marks. So let me go ahead and count them up here. I've got 1, 2, 3, 4, 5, 6, and there's 7. Okay, now there's 12 total boxes, so I'm suggesting that my chart says the probability of getting a 2 or ahead is 7 boxes out of 12, or 7 12s, just a little bit better than 50%. Now watch what happens if I just try to calculate it like a mutually exclusive event. I'm going to run into a small problem. I'm going to bring this down here, give myself a little more room. All right, and I know the probability of getting a 2 on a 6-sided die is 1 out of 6. Okay, I know the probability of getting a heads on a coin is 1 out of 2. Now, if I add those numbers together, I need to get a common denominator. Hopefully, you know how to do that by now. I mean, you are in 8th grade. You should be able to add fractions. I take the largest denominator, namely 6, and I'm going to count by it until I get a number that the other denominator, in this case 2, goes into evenly. 6. I'm going to stop because I know 2 goes into 6. So I need both of my denominators to be 6. This denominator right here is already a 6. I won't do anything. This one's a 2. To turn it into 6, I'm going to multiply by 3. But if I multiply downstairs by 3, I have to multiply upstairs by 3. Otherwise, I change the fraction. I mean, if you stop and think about it, this makes wonderful sense. 3 over 3 is the same as 1. So right here, I'm actually multiplying by a very special form of 1. See? That's 1. I'm really multiplying 1/2 by 1. Now, it's not going to look like 1/2. You know, normally when you multiply by 1, you get the same number you started with. It's not going to look like a half, but it's going to be the same as a half. So I'm going to get 1/6 plus 3/6, which is a half. Okay. Now the problem with that comes out to be 4/6. If I blow that up so it has a denominator of 12 to compare it to the one in black, I'm going to multiply both the numerator and the denominator by 2, just blowing up my fractions so that I can see what it looks like. It seems too large. Yeah, I get 8 12s, but I should only be getting 7 12s. You see, what we're doing in this blue example is that we've accidentally counted this box in yellow twice. That's what's happened. So here's what we need to do. We need to erase this work here. I'm going to keep that work above it because that's a good start to the problem. But to make sure that that box doesn't get counted twice, I need to subtract the product of the two probabilities. So it would be minus 1/6 times 1/2. All right. So I can still do this. I can still do the 1/6 plus the 3/6. That's good work. But now because of the order of operations, I'm going to do this multiplication here. Remember, the order of operations is parentheses, exponents, multiplication and division before addition and subtraction, right? So I'm going to do the multiplying here. So I'm going to need a minus sign. And 1 times 1 is 1. And 6 times 2 is 12. So you see, for mutually inexclusive events, things that can happen at the same time, I can't just add them together. I have to subtract the product. Did you hear that? I add them together, but then subtract the products. I add the two probabilities together, but then I have to subtract the product of the two probabilities. Did I say that enough times? All right, 3 6 plus 1 6 plus 3 6 is 4 6 minus 1 12. Oops, not 11. Excuse me. Yikes. 1 12. Now, I need a common denominator, which hopefully you can realize is 12 in this case, right? Okay, so I'm going to multiply by 2 here, multiply by 2 there, and I'm going to make this fraction look different. I'm going to make it look like 8 twelfths minus 1 12th, and look at that, I get 7 twelfths. Yeah, that's how that works. So, I'm going to give you a couple examples to try. Hold on one second. Okay, here's two examples on a six-sided die. Calculate the probability of getting an even number or a number greater than 3. That's on one roll of die. And the second example is the same situation, six-sided die, one roll. Probability of getting a prime number or an odd number. Now, before you actually go and do this, first you got to decide, are the events, are they mutually exclusive or are they mutually inexclusive? Okay. The second one has the multiplication, this one here. These are events that cannot happen at the same time. Can't be at the same time. And these are events that can occur at the same time. Can occur at the same time. And this is the one that has subtract the product minus the product. Product is multiplication. All right, I'll go ahead and pause the video and you can decide. There's actually a third example down here. Okay, I want you to do all three of them before you unpause the video. If you're still watching at this point, I think you're ready to determine problem number one. I've got a six-sided die, an even number, or a number greater than 3. Well, I'm going to list the even numbers on a six-sided die. There's 2, there's 4, and there's 6. Now, a number greater than 3, that would be 4, 5, and 6. Do you see numbers happening more than once? I sure do. Okay, I see the 4 and the 6 showing up in both parts. These must be mutually inexclusive, and so I'm going to have to do the subtraction on this. So I'm going to go ahead and find the probability of getting an even number. Well, 2, 4, and 6, that's 3 even numbers. It's 3 out of 6. The or means to add. By the way, I should mark mutually inexclusive. All right. Now, a number greater than 3 looks like there's 3 of those out of 6. Except now I have to subtract the product of 3 out of 6 plus 3 out of 6. So, oh, wait, did I do that right? 3 out of 6 times 3 out of 6. Yeah, I have to subtract the product of the two events happening together. I said multiply, I said product, but I wrote plus, so forgive me for that. Well, let's see here. I know that 3 6 plus 3 6 is 1 whole. And I know that these simplify both down to 1/2. And that's also 1/2, right? 3 over 6 is the same as 1 over 2. 1/2 times 1/2 is 1/4. And so, if I do 1 minus 1/4, now some of you are going to freak me out here. You don't know what $1 minus 1/4 is? Sure you do. It's 75 cents or 3/4. Okay? So it's a 75% chance, or 3 out of 4 chance to get an even number or a number greater than 3 if I roll the die. Okay, one time. All right. So let's see here. Let's check out number 2. The probability of giving a prime number or an odd number. Well, can I get a prime number that's also an odd number? Absolutely. The prime numbers on a 6-sided die would be 2, 3, and 5. 1 is not prime. Okay, prime number must have exactly 2 different factors, the number 1 and itself. 1 is not prime because it only has 1 factor, 1. That's it. Has to have 2 to be prime. Okay, an odd number. Well, I think an odd number is going to be 1, 3, or 5. And you look at this, I think that these numbers are going to show up. 3 and 5 show up twice. I think this answer solution is going to be very much the same as the last one. This is going to be 3 out of 6 plus a 3 out of 6. And then I have to subtract the product of 3/6 times 3/6. And I'm not going to go through the whole problem again because it is also going to end up being 3/4. Okay. Let's look at this one here. On a 20-sided die, a prime number, well, I better list the prime numbers on a 20-sided die. There's 2, 3, 5, 7, 11, 13, 17, and 19. It looks like there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of them. Okay. Now, a number less than 4. Well, that would be a 1, a 2, or a 3. Okay, on one roll of a 20-sided die. And if I look here, the 2 shows up and the 3 shows up. So these are also mutually inexclusive events. So I'm going to do the probability for it, but then I'm going to do this. I'm going to add the probabilities together, but I'm going to subtract the product of the probabilities. So this was 8 out of 20. Right? There's 8 numbers up here, right? And there's 20 possible numbers on the die. I'm going to add that to 3 out of 20. Okay, there's 3 of them right there. But then I have to subtract 8/20 times 3/20. And when I do this, I like to simplify fractions, but in this case I might not. Here on the left-hand side, I'm going to get 11/20. All right. And I'm going to get 24/400, right? 20 times 20 is 400. Now, the reason I didn't simplify is I need a common denominator. Well, okay, yeah, I'm going to use the common denominator of 400. I got to figure out how many times 20 goes into 400. Well, if I do 20, 40, 60, 80, 100, I get 5 for 100. Well, 200 will have 10, 300 will have 15, 400 will have 20. So I'm going to multiply this by 20 and this by 20, and this will give me the common denominator of 400. So when I do that, 20 times 11, I think it's going to be 220, right? Yeah, and that'll be over 400 minus 24 over 400, and 220 minus 20 would be 200 on the nose. Take away 4 more will give me 196 over 400, and that is definitely going to simplify. I know for a fact 4 is going to go in to both of them, so I'll divide them both by 4, and I'll get my new fraction of 100 downstairs in the denominator, right? And 4 would go into 200, I believe, 50 times, right? If I divide by 4, it's going to go in 50. So it's only going to go to 196. It's 1 4 less, so it's going to go in 49 times. And I believe that is my probability right there. Okay, that is the lesson for today, pre-algebra. We'll see you in class next time. Mr. Lawrence signing off.